Cool. Quick shout out to my work, because I basically borrowed some of their time to write this talk. Yeah, we're not currently hiring for Ruby, but hiring soon. Work at Afterpay. GraphQL and Ruby. So a quick, well, how am I going to see hands, Mike? You didn't think this through. A quick show in the chat is who has had any experience whatsoever of GraphQL? Yes, yes, a little, some, yes, yes, sure, great. Anyway, for those that haven't, GraphQL is a language for APIs, runtime for filling those queries with your existing data. So if you look at like specifically a Rails or, well, sorry, a more RESTful API, usually with REST, you publish a spec, a Swagger, or whatever you want, but basically the server sort of provides the menu. Here's what data and queries are available. Whereas GraphQL kind of flips that a little bit. Like a server request, you make a request for all this data, you get it all, whether or not you wanted all of that data or not. With GraphQL, the client defines what data it requires. So that's kind of the fundamental difference, if you will. So if I take a client-server relationship, or we have someone who wants all the things and a server that's like, I know things, I build banking applications, building a banking application at the moment. And typically you sort of run into a request flow like this. The client's like, oh, I would like my accounts, please. Sure, here you go. There's your accounts. Enjoy those fresh accounts. Great. What about the transactions for those accounts? Well, no worries, chum. Awesome. What about any sort of unread notifications, so I can render that sweet little badge or something? Yeah, nothing at the moment. Great. Well, in the context of Afterpay, well, we'd also need Afterpay orders and et cetera, et cetera. And anyway, you end up with this sort of cascading waterfall of network calls. And each of those network calls, particularly if you're building sort of applications for mobile phones, takes 200 to 500 milliseconds. Like it's a full sort of server round trip, and it can be really bad on spotty connections, which yeah, I mean a lot of people still are, even with all your 4Gs and COVID causing 5Gs and all those sorts of things. So that's a non-starter. So we have instead our Galaxy Brain server, and the client is like, I would like my accounts and their transactions and notifications and the server's like, live your best life, ship it. And yeah, I mean, basically that is great if you want to go fast. So let's do a demo. So I'm not going to walk through how to install GraphQL Ruby and get set up. The docs here, I don't know if you guys can see that. Is that too small? About right? Yep, can see it. Sure. Yeah, mate. Cool. So anyway, you go to graphqlruby.org and they've got great setup instructions. You basically do these things and you can be up and running. So we have our little app, and our app has, well, currently we have accounts, name, balance, transactions, and this sort of shape, that sort of query shape, it looks kind of the same as to how data comes back. So we can run this request and we get back our amount in cents and transactions, accounts, and savings account. Super cool. But let's suppose we want more data. So one of the things that I love about GraphQL is it's kind of self-documenting. So following on from Dana's talk, I don't even need to write documentation. It does it all for me. No, but it kind of does. So like we can go for our accounts and we see, ooh, I've also got this notification count. Let's add that in there. So notification count. We run that. And so we didn't make a server-side change here. We've just simply got the same kind of single request coming back. Then for our accounts, we're adding like all other exciting features. We need to show the BSB and the account number. So we can add those as well. And we start to build up like a big payload of sort of everything we need in order to render our screen. So what this kind of looks like from a code perspective. So we have sort of our query type, and we have this information that we make available. So we have accounts, and that from a GraphQL Ruby perspective, that is an account type. And then you've sort of got to define the implementation for that method. So for here, this is heading into a sort of an active record. Give me all my accounts for the customer. And for notifications, well, that just returns 7 because I didn't have that much time to work on my demo. Afterpay wasn't that generous. No, they were fine. But we can add in our suite from our account type. Let's say we add in our suite emoji feature. So we can go into account type. And yeah, we've got emoji support. We added that. And ooh, look at that, emojis. But one of the really useful things, so I found over time that REST endpoints, they kind of grow and they get slower and they get slower because basically the server has to do more and more work fetching more data. So if a customer, so for example, if our front end, we're like, nah, BSB and account numbers are old hat. People are transferring exclusively via emojis these days. And we no longer need to ask for this information. Well, all of a sudden, the server simply just doesn't need to calculate that. Now that can be really good when some fields sort of aren't entirely super cheap to retrieve data. So we've got our notifications, we've got our accounts, but let's say we also then want, or we kind of want the transactions for those accounts. So we can add that here because our account type defines a field transactions. Ignore this one. This is for later in the demo. Transactions, they have an amount, and an amount also has an amount in cents. As a matter of fact, we can also add a sweet formatted amount to this. So this is the balance is a money type, where a money type is something I wrote. But basically uses a currency, amount in cents, and a formatted amount. So we can sort of run that there, and that will give all the transactions on our account. We might also want a description. So you can see how you can sort of like dynamically build up APIs from a client perspective. So that's kind of the gist of GraphQL. And why you would do it. So, benefits. What was good about that? So it's easier to comprehend what data is important to the device and client because the client is always telling you, hey, I care about these fields. You can sort of, with REST, it sort of becomes quite difficult to deprecate, particularly if you've got like iOS and Android apps in the wild to actually deprecate fields from your APIs. Whereas with GraphQL, you can sort of instrument and know the second usage of certain fields is very low, which means you can delete them. So that's super handy for maintainability of an API. It means testing is easier. So we build a iOS application and an Android application. And what we simply do from a Ruby perspective, so iOS and Android testing is a white hot mess. It's bad for all sorts of reasons. It's slow, it's flaky. You've got to run it, if it's iOS stuff, on Apple Gear or pay exorbitant fees for basically running it on effectively Apple Gear via AWS or BuildKite. So what you can do with GraphQL is you can simply export all the queries that your application can possibly make and then run them directly against the server. So it's a cheaper form of testing that still gives you some level of confidence that your server can actually serve what the client requires. So as I talked about, when it's safe to deprecate fields, less round trips. So yeah, you make one request as opposed to a whole bunch. And I'm always a big fan of this. Like front-end developers, they have enough things to worry about with like phone sizes and browser dependencies and all that sort of stuff. So anything you can do to have kind of a dumb client, smart server is good. If the client is smart, well, you end up needing to replicate logic on iOS, on Android, on web. If the server does that logic, well, then it only lives in one place. So wherever possible, I try and do that. But maybe that's opinionated. Some people may not say that's a benefit. I think it is. And it's more performant for the server. So the server spends its time calculating exclusively what the client wants. So what are the downsides, Mike? Well, so authorization is a bit harder, but probably ultimately nicer. And what I mean by that is you kind of need to do authorization on a field by field level. So if you have, like, for example, multiple levels of users, if it was a REST endpoint, you might simply say, okay, admins can access these 5 endpoints, but can't access, the customers can't access these 5 endpoints. Whereas with GraphQL, depending on how you set up your graph, you actually need to go down into admins can access this specific thing on this specific resource, but customers can't, which can be a little bit more challenging to conceptualize and review. But I think ultimately it's works out nice, but whatever. I think it's harder for engineers to pick up. So this is possibly controversial, but there's like engineers have spent, well, maybe it's not. Engineers have spent 15 years working with REST APIs. REST APIs have a really good curlability. You can, particularly depending if there's not a lot in the way of authorization, you can chuck them in a browser, in a browser bar and see like the actual JSON that's returned. So I think that's a downside of GraphQL. Every single request is a post request to one endpoint and has a data in a very, very specific format, which yeah, I'd say is generally more challenging for engineers to pick up. Yeah, again, it's sort of more effort to avoid N+1. So the actual data that your server has to retrieve and respond with, you kind of don't know it at deploy time. I mean, maybe you will if it's not sort of a public API, but maybe you won't. In which case, you need to sort of look at what query is coming in from the client, and there's all sorts of like loader patterns to sort of avoid. Yeah, basically doing sort of N+1s, but there's a lot of good work, primarily out of like Shopify, for how to avoid that sort of stuff, like with batch loaders. And yeah, from a security perspective, few gotchas. It's a sharp knife, and you can yeah, cut yourself. One is recursive queries. So as an example, if you look at what I was doing before, I had an account, and that account had transactions, and a transaction, well, I mean, that belongs to an account, and that account, of course, has transactions, which in turn, well, that belongs to an account, transaction, and yada, yada, yada. So if your graph isn't a sort of directed acyclic graph or DAG, you can, as a client, quite cheaply give the server very, very expensive things to calculate by saying, get an account, get all its transactions, get all the accounts for those transactions, get all the transactions for those accounts, and so on and so forth. Obviously, there's ways around that, but it's just yet another thing that you have to do that you wouldn't necessarily have to do with a REST endpoint. And this is another one, inadvertent exposure via graph traversal. So what I mean by this, so let's suppose you had a graph where a customer made payments, and payments were to a customer, but so on this customer attribute, you can select the customer's name, you can select their address, and you can also select their payments, the payments that they made. And because a payment is something that's happened between two people, well, on that, for the recipient of the payment, you might intend for someone to only be able to select the name. But if you've mounted the exact same sort of customer object, you can actually go from sort of, well, no, I now want to get the people I've made payments to, and then also ask for their addresses as well. And GraphQL will happily send that back to you, depending on how you've defined your schema. So, side note, does anyone remember these books? Choose Your Own Adventures.
I love those books.
They were great books. They were great books. Well, this is the Choose Your Own Adventure of Mike's GraphQL Ruby talk. So I'd like to hear more about authentication, Mike. Turn to page 403. I'm not so sure. How would you handle validation? Turn to page 422. Seems great, Mike, but what about pagination? Continue to next page. So I'd like everybody in chat to say, or I mean, it could be none of these options, in which case we'd just die. But what would you like to hear more about? 403, auth, hidden, auth, 422. All right, we're going to go with auth. 403s it is. 404s. Ha, that's not found. Yeah, that page got torn out. Okie dokie, authentication. So there's multiple different ways you can handle it, but here is a pattern that I have seen well. It works. So if we look at a GraphQL, so from a sort of a Rails perspective, if this was like a sort of a traditional Rails app, we'd have like heaps of like exciting resources here. We'd have accounts and all that sort of stuff. Rails, you get one endpoint. You get a post to this thing, and it is executed. And for this little UI that I'm serving, well, that's mounted on this endpoint here. So in our graph controller, typically for authentication, there's heaps of different ways you can do it. But let's suppose we're passing in some sort of bearer token. So we're going to have, like it could be like well, if it was a devise kind of world, we might have a current user object, but you can basically from this sort of main controller, and this is all generated code, by the way, I didn't write any of this sort of thing. You can pass in context that is available at all points to your query. So typically a pattern I've seen work quite well is to have some sort of object that represents kind of the query context that is being made. So let's suppose here we have a tenant class, or you could call it, I don't know, well, let's go with tenant. And then in our tenant class, we would do something like this. So you would go, okay, let's pass in the request, and we could grab a authorization token. I haven't actually run this code, but it would probably work. I wouldn't use this code in production, but to basically grab some sort of auth token, find a session record or OAuth tokens record, get the active ones, and look those up by a digest of that auth token, because we would be good security conscious people and wouldn't actually store the undigested token, would we? No. And then in our account class, we would do, our account, query type. We would do something like this. We would change this this thing to be context dot authenticated customer dot accounts. And obviously, yeah, I mean, this would blow up if this returns nil. So we put guards around it or do whatever we wanted to do. But that is a method to do basically authentication. And then you would just ensure, much like what you would in like a normal Rails object, that everything was scoped off the concept of this tenant object, and everything would be great. Does anybody wish they didn't take that path and want to learn anything else? Walk the tree. Pagination. Oh, pagination. All right. How would you do pagination? So I'm just going to undo this because that code is clearly not going to work. No, it probably will. So pagination. Pagination works quite nicely in that you provide, it's this thing called connections. Pagination. Anyway, I would strongly encourage you to read the thorough technical documentation. But we have so I mounted on our account type the exact same transaction object twice. So one is transaction type, the other one is transaction type dot connection type, and this kind of makes things happen. So we now page transaction. You don't. So where a normal transaction, you would go straight to retrieving what was it? Description, location. Oh, by the way, side note. Where are we? Tags. So I had to set up like fake data, and I didn't realize that Faker the gem actually supports Super Mario and Zelda as like fakers. I've been using like Faker company name for like years of Rails development, and now you can actually set all your fakers up with like characters from Nintendo games or whatever. So anyway, we have my descriptions are items from The Legend of Zelda, or the Pendant of Courage. So anyway, very exciting. It's an important development, and you should use all of that for your development going forward. So with pagination, you have this sort of thing called edges and node, where the node is still the transaction. So we can go, we'll get its amounts, thing out, and description. But then off the basis of this, you can say, okay, I want the first 3 transactions. And that will return me, let's just get rid of this. We don't care about this anymore. Yeah. And that will return me 3 transactions. But on those, you also have a cursor. So this is again sort of straight out of the box, provided by GraphQL Ruby, and the cursor is built off the active record ID. It's actually a base 64 encoded active record ID, but the paginations, and this kind of works out of the box with the if you're using Relay or Apollo as a client to GraphQL. But we can say, okay, the last transaction we got was MW. So then you can add to this after MW, and then we will get an invalid input. Oh, what did I do? It's in my history. Geez, I've written a lot of these. No, I'm sure you can do this. Invalid input. Oh. remember how I did it. Well, anyway, it's something very, very similar to this. And I should have saved precisely how I did this, but I swear it was all working. Yep, that's roughly how pagination works, but with a little bit less of that. MW, valid input, MW, no. That won't be valid. Oh, no, it was right. Ha, shout out to Lang. Yep, you need the actual cursor that was used. You're the best, Lang. Cool. And the only other one was validations. So we didn't talk. So all of this is great for reading data, Mike. But what about modifying data? So let's suppose we have over here we have our sweet ability to make a payment. So these kind of look much like the types I was talking before. We will have a make payment mutation. It has sort of the fields or data that you can get back of it, and it has arguments. So this is kind of the inputs to this kind of GraphQL query. We can hit play on that, and we get our payment ID of 123, which is an integer. So if you want to do validations, you'll probably end up making a nice, making a bunch of different sort of modifications to the base mutation class to give you some sort of Rails-isms with like active record errors or something like this. But basically, as a very, very simple one, there's two ways to kind of do client-side errors. One is to treat errors as data, and this is the approach that's recommended by the GraphQL Ruby gem. So where are we? Errors. They say yeah, error handling. Well, validation. They basically say treat errors as data and provide a data object back, and we can provide the field and the message. And if we give it an invalid BSB, so sorry, this is the input that I'm giving to the query down here, then I'll get my sweet message that your BSB is not valid. There's another way to do errors, and if you're my iOS developer, he goes, Mike, I don't want errors like this because this is sort of more work for me to handle. And you can basically in here raise, I think it's like GraphQL execution. What are the odds I've got this right? Pretty slim. Give it a punt. You're like in a big city? No, totally not that. But yeah, basically you raise a GraphQL exception error. Your documentation would be in here as to how to precisely raise that error. There you go, GraphQL execution error. That. And then you end up getting errors not in the data block, but in the this. So the actual data block will return null, and you end up getting a sort of a top level errors object returned. GraphQL also does this sort of stuff to go, oh, okay, the precise part of the query that failed was line 2, column 3. So it's literally, it said the error occurred right at this character here when it tried to resolve it, which is kind of neat, but it was surprising to me the first time I saw it. Anyway, that's a quick run through of GraphQL, how to do it. We chose our own adventures. We got to the end. Any questions? I think there was one question in the chat. saw. How does GraphQL compare to using render object include? Yep. Yeah, I think Mike, the difference is with GraphQL, yeah, it's basically like a sort of a pick and mix. If you don't want the whole of object, or sometimes you conditionally want my thing. Yeah, it's just kind of a bit of a different concept with like there's other stuff that I didn't really talk through here, which is the ability to have like persisted queries, which is kind of neat from a security perspective in that you end up baking in at runtime, okay, what are valid queries for a client to make? So this is kind of what Facebook does for their app. So in development, they can make whatever queries they want, but when like Facebook, you've got to imagine they're shipping like many software to many people, and they simply end up compiling kind of all these queries, and then the front end basically goes, yeah, execute query 1, 2, 3, and here's the inputs that I want to give. Execute query 4, 5, 6, and here's the inputs, which is again faster from a sort of a data perspective, because you're not even sending a big payload to the server anymore, and it's neat for security. For what situations would you recommend not using GraphQL? Yeah, a public-facing API. So when we built so I used to work at Upbank. When we built the public API there, we chose to do it in REST. Probably despite a few of our engineers' wishes, but basically we felt that REST is better to, if your audience is other engineers, then I think GraphQL is a bit too new to be like, if you want it to be as adopted and you're not going to write clients for people, I would use REST over GraphQL at that point. Yeah, any other questions?
There's another one in the chat from Alex.
From a traceability perspective, how do you model the equivalent of common highlight? Aha, yes. Yeah, so what I end up doing most of the time is building basically like sort of an operations store of when were queries last executed by what client. So then you can go, okay, well, let's suppose we have, I don't know, 100 different apps in the wild, right? Because that's what happens over time. Punters like their apps. And yeah, if you effectively like SHA a query, you can then go, okay, this query was made by build 1, 2, 3, and it was last received 10 minutes ago. And then over time you go, okay, well this query's never been made anymore. And then I guess from that point you can look at the queries being made and work out, okay, well what specifically the fields on those queries aren't being used anymore. I'm sure there would be other probably smarter ways of doing it, but yeah, I haven't done them yet. Yeah. Any other questions? Did that kind of make sense?